Hello, I hope this video finds you well. We're going to look at the Mod10Div10 algorithm. And this is an algorithm that I often use and teach students to access each digit in a number. It's really useful, but it requires you understand two things. You understand what modulus is, and you understand what integer division is. And so that's kind of what I'm going to go through here. On a side note, this is my first time using Visual Studio's code, and so I'm starting to record it. Some of the students in my class use this, so I figured why not jump in and use it as well. It seems like a pretty good tool. Alright, so the theory here is the first thing we're going to talk about mod. And the mod operator simply gives the remainder when division is performed. So if I have 14 mod 3, and mod is represented using the percentage symbol, I get 2. Why is that? Because if I take 14 divided by 3, I get 4 remainder 2, so mod just gives me that remainder, which is 2. There's two special cases here that you should be aware of. Not really special, but they're ones that usually cause students some pause. 56 mod 0 is undefined because you can't divide by 0. Likewise, 0 mod 56 is 0 because 0 divided by anything is 0. So if we just come down to the bottom here, let me just make x, and I'm going to say x equals 14 mod 3, and I'm going to print x here. If I save this, come down to my terminal here, Python 3, and there I get 2. Notice now if I hit 14 mod 0 and I save this and I run it, I get an error. And the error is coming up because I'm trying to divide by 0, which I can't do. Likewise, if I say 0 mod 14, and I save this and I run this, I get 0. Now, one of the things that's really useful about mod is that we work in base 10. And so if I take a number and mod it by 10, I'm going to get the units digit. So let me show you what I mean. 231 mod 10. So if I save this and run this, there we go, I get a 1. So notice it's getting 1 because 10 goes into 231 23 times remainder 1. And you can quickly understand the pattern here that, again, anytime I mod by 10, I get that units digit right there. 45 mod 10 is 5. And this is going to be useful in a minute. The second operator you should know about is what's called integer division. Now, what integer division is when you divide two integers and the result is an integer. Python's actually pretty forgiving. So if I say x equals 3 divided by 4 in Python, Python will look at this and say, okay, 3 is an integer, 4 is an integer, and you can see it there. And it's going to assume that you want a float or a double, which is a decimal value, returned. So it's actually going to give you the decimal here. So if I print this and I say print x, and I run this, there we go, 0.75. Okay? Now, other languages like Java, for example, if I perform this, it will automatically do integer division. So if I say x is equal to 3 divided by 4, I will get 0, because what integer division does is it takes the value and just chops off the decimal. Really important, it does not round. It just chops off those decimals. So when I print this here, I get 0.75. But if I want integer division to occur, I can put 2 slashes. So if I save this and I run this, down here at the bottom, I get 0. And so now, if I take integer division, and let's play around with 10. If I take 34 and I integer divide it by 10, and I run it, I get 3. If I take 23, integer divided by 10, I get 2. Are you noticing what's happening here? 145 if I integer divide it by 10. I get 14. When I integer divide by 10, because I get 14.5 here, I essentially just chop off the decimal. So what integer dividing by 10 does is it removes the units digit. And these two things together, the fact that mod 10 gives me the units digit and integer divide by 10 gives me removes the units digit, means I can write an algorithm to go through each numbered sequence. And that's what we're going to do here. So let's just make a num. We'll call it num, and we'll put a number like 345. And notice if I take this, if I say print num mod 10, and then I say num is equal to num integer divide by 10, and then I'm going to print num. So if I take this value, I have num, which is 345. I print the num mod 10 value, which will give me 5. Then I integer divide it by 10, which gives me 34. And there it is. There's my mod value, there's my integer divide value. And so now if I take the new num and I print num mod 10 again, and I print, oops, and I say num is equal to num 10, and I print num, this is actually, can't see my code with all this pop-up, this is new to me, and I print num, what's going to happen now? Well, let's just clear this to give a little more space. So notice, I mod it by 10, I get the 5 from 345. I integer divide it by 10, I get 34. I mod it by 10, I get 4. I integer divide it by, and I get 3. And so if I do this one more time, if I just take this chunk of code and I do it one more time and save it, now what I've done is I've gotten, there's the first digit, the 5, there's the second digit, the 4, and there's the third digit, which is the 3. And I've accessed each of those digits, and I can do whatever I want with them. Now, this isn't super convenient because, you know, if I had 345,004, there's going to be a lot more digits. So what I'm going to do is I'm just going to work with this information here. And I'm going to set up a while loop. And I'm going to while num is greater than 0. Because notice, every time that I actually integer divide by 10, I remove a digit. And once I've removed all the digits, I'm going to end up with 0. And that's when I know I'm done. So now if I save this and run it, there are the digits. I get 5, I get 4, I get 3. Because the first time I come in here, we mod by 10, giving me 5. I integer divide by 10, num is now 34. And actually, let's trace this here. So num, I'm going to say is num greater than 0. There we go. So num starts off as 345. Is 345 greater than 0? Well, that's true, so we run loop. And num is going to equal num, well, let's do 345 integer divide by 10, which equals 34. So then we start the loop again, 34. Well, before we start, we say is 34 greater than 0? And again, the answer is true, so we run loop. So num is equal to 34 integer divide by 10, which gives me 3. So I have 3. Is 3 greater than 0? Well, that's true, so I run the loop. So num is equal to 3 integer divide by 10, which gives me 0. 0, so it's 0 greater than 0, and that's false. So we exit. And that's it. So this integer division process with this while loop allows me to go through each digit. And now what I can do is instead of printing it, I can do what I want with it. And in our case, we're going to total. So I'm going to make a variable called total, set that to 0, and say total equals total plus num mod 10 to get that integer, get that units digit. And now let's just print our total, save it. Let's clear this up. Oh, I made a mistake. Oh, I didn't close my comment down here. There we go. That's better. Let's save it. I spelled total wrong. All these mistakes. There we go. And I get 12. Because 5 plus 4 gives me 9, 10, 11, 12. And this is a really powerful and useful algorithm that I think students in the DP Computer Science course, and I also think in the AP Computer Science course, because it does come up in AP Computer Science questions, should know. It's really useful, and if you have any questions, please don't hesitate to reach out. Have a great day.